Heinemann Higher. Chapter 6 on differentiation, mixed exercise 6S at the end. Number 11, sketching the graph of the derivatives. Right, now in the first one, it says that this is the graph of a quadratic function. Well, straight away, if f of x is of the form of something where x squared, or some multiple of it, is its highest term, then its derivative will have as its highest term something like 2x, or some multiple of x. In other words, it's just going to be linear. The graph should be a straight line. Same with this one. In part B it says this is a graph of a cubic function. In other words, its highest term involves x cubed. Well, there may be some other multiples and so on. So its derivative's highest term should be something that involves x squared, not necessarily a 3 of course. And an x squared one would give you a parabola. So the answer to this one should be some sort of parabola. So to part A, I want to draw the graph of the derivative of this. Well, I'll put in the axis here. Then what I'm going to be drawing is not the actual heights of them, their actual values, the value of the function, but the values of their gradients at each of the points. So if the gradient's positive, I'll be plotting a positive amount for it. If the gradient's 0, I'll be plotting a 0 amount. And if its gradient's negative, I'll be plotting a negative amount, even if the actual point happened to be up there. So the first part would be this. Where is the gradient ever 0? Here, at the top, at 3. So at 3, the gradient is going to be 0. The value of the derivative is 0. Before 3, it was going up. So all the values before 3 were positive values. So it should be going through this region here. After 3, the gradient turns negative, so I must plot negative values. So it must pass through the region there. And since you know it's a straight line, it's not going to be some sort of curve that goes down through the two regions. It'll just be a straight line through the two regions, like this. Well, the only thing I know for certain is it's 0 at 3. And these original zeros here, the negative 1 and the 7, have no significance in this graph because the gradients had some quite large values, positive in that case and negative in that case. And that's all you would need for that. The only thing you might want to do, which isn't actually necessary, is make up a sort of table of signs, like a nature table for that. You could do that if you wanted, but it's obvious when it's going up and going down. You could say, well, how would you have constructed that point? Well, when x was 3, before it and after it, and here's the derivatives here. So it was 0 there, before it was positive, and after it was negative. But that's just you were doing by saying it had to be positive and negative there. Right, for this one, I'll need the axis again, and then it's the same as before. Right, it's not the actual values I'm plotting. I don't care whether the original points are positive values or negative values. I'm plotting gradients. If it's up, it means it was moving up. Then if it's below, it means it was moving below. So when was it 0? It was 0 here. It was horizontal at that point. It was horizontal at 0, so its derivative was definitely 0 at 0. It was horizontal here when x is 3. So at 3, its derivative is definitely 0. Then what happened before and after? Well, on its way to 0, it's heading up. It's got positive values. So I'm going to be plotting positive values here. They happen to get smaller and smaller as they do until they reach there. So I want it to pass through that region. Between 0 and 3, it's going downwards. Starting off just a little bit, sloping down, then a lot, and then levelling off again. So I want to go through a negative region there. And after I leave 3, the gradients all then go positive again. So I want to plot positive values, so it's got to pass through that region. And you know from the derivative of an x cubed graph, it should be an x squared graph, so obviously it's going to be a parabola going through them. You could make up a table like that if you liked, but it isn't at all necessary because it's obvious just from these things you've put here. But of course you wouldn't be putting them there, you'd just be thinking of those things there. So the graph would look like this, only maybe a better looking parabola than that, without these wee squinty bits on it. And that would do it. If you absolutely had to, you could have indicated that with a little table of signs. By putting that in, you could have said, well, it was 0 at 0, the derivative was 0 at 3, and what happens before, between and after. So it was positive before, it was 0 at it, it was negative there, it was 0 at it again, and then it was positive afterwards. Positive, going negative, back to 0, positive again. There it is, question 11.